Recording in progress. Welcome everybody to Lecture 7. All right, so today we're going to be doing transparency, transmission, and refraction. Basically glass and liquid. We're going to define liquid for our purposes in shading and lighting as something that has some transparency that you can see through, even if it has color. So you can see in the Zen garden scene on the table, we've got a wine bottle, we've got a wine glass, and we've got liquid inside the glass. We've got geometry in there. So today we're going to be working on glass and liquid. Your liquid inside that wine glass must be slightly transparent at least. I know there's a lot of red wines out there that are almost completely dark. You can't see through them. They're almost completely opaque. But for our purposes, for this, we need to know that you can create a red wine, a white wine, whatever kind of wine you happen to put in that glass that has some transparency. The bottle also needs to be empty and you need to be able to see through it. If it's too dark, that kind of defeats the exercise. All right, so let's clear that. All right, so I'll have office hours tomorrow, Thursday, 10 to 4 p.m. Eastern Standard Time. I'll also have them next Tuesday. Don't forget, if you need some extra help, Frank or Ari will be doing the Zoom Open Lab tomorrow from 1 p.m. to 5 p.m. Eastern Standard Time. It's optional. We can give you help in Discord also. We can screen share in Discord, the audio, the video, it works pretty well. The Open Lab has an advantage where if there's a bunch of people all with the same question, it's a lot easier to get a group in Zoom than it is in Discord. Discord gets pretty sloppy. So we have two venues for you to get help tomorrow if you need it. So as I mentioned, today we're going to be doing transmission, which is actually fairly simple concept. Refraction, transparency. We're going to be dealing with the index of refraction. Now, the index of refraction is going to be a little bit different than the refractive index database that we used the other day. The idea with that refractive index database is it catalogs everything, not just transparent materials. And a lot of times when we think of index of refraction, we think of those transparent materials like glass or water or even air. Those are the most common ones that we come in contact with all the time. So we're going to talk about how transmission, how refraction, how transparency works in the AI standard Arnold material. Like everything else, there are a couple of little quirks or idiosyncrasies inside the AI standard surface. One is it's really easy to make transparent glass. However, we don't get an accurate shadow with transparent glass like we do in the real world. All right, so I have a couple of pictures that I'm just going to throw out there real quick. There we go. All right, those aren't the ones. Nope. Ah, those are the ones. All right. So here I have a couple. It was a nice sunny afternoon. Went outside, I had a whiteboard I threw down. I took a clear wine glass and I took a colored smaller cordial glass. Put them out there because I wanted to see exactly what it looked like in direct sunlight. So you can see that we have a couple of things going on here. So we have very distinct shadows. And you can see the clear glass shadow is actually fairly dark on the edges. And we also have all this little shimmery, kind of white, sparkly reflections here. They are called caustics. And we have them here too. That's a result of sunlight hitting the surface, going through it, but as it's going through, it's also reflecting. And it's just like sunlight going into a pool, where all the little ripples in the water create all the shimmery patterns at the bottom of the pool. Those are caustics also. So those shadows are crucially important for us. And like I said, Arnold will give you nice looking glass, but the shadows just, they aren't there, basically. So we have, I hate to say this, we have a workaround in order to compensate for that. So it's a little, you'll probably be slightly confused and terrified the first time you see it. But once you do it a couple times, it is fairly straightforward because it's the same process every time. It's not like everything that you do is going to change. The process to get a shadow requires two Maya utilities that plug into the AI standard material. We set settings in there. They pretty much work for any scene, any surface. So once you understand that part, you'll be able to get shadows. Now, here's the deal. If you've got things like windows, we don't rely on seeing shadows in windows, right? We just rely on seeing transparency. So with windows, we don't have to worry about creating shadows. Creating that glass effect is perfectly fine in Arnold without any extra work. And we'll talk about that also. And we'll demo that because the interior scene has a display layer where there is glass geometry. By glass geometry, I mean it's a plane in the window that is basically our glass. We're going to turn that on, and then we're also going to make a couple of adjustments because we treat window glass slightly differently than we do all the others. All right, so brief overview. All right, any questions before we get going? Okay, how about out there in the Zoomosphere? Any Zoom questions?
No, sir.
All right, Gaetano, questions? All right, thank you. All right, so let's talk about direct transmission. Direct transmission occurs when you have light rays passing through, I'll call it a medium. A medium could be a surface that's transparent or a body of gas like our air. Now, usually air is fairly clean and clear, and light passes through it more or less unobstructed. That means it usually doesn't bend or refract. It usually passes through unless you're in Florida in the summer and it's really humid outside. All that moisture in the air, if you take a look out across the parking lot, all the moisture in the air is getting activated by all the heat coming off of the ground. And consequently, it looks like everything's very wavy. And that's just because of all the moisture particles in the air moving around, causing a tiny bit of refraction when you look out over the distance. That makes sense. Anybody? I'm assuming everybody's probably seen that phenomenon, especially in Florida or anywhere where it's hot and humid. All right, so direct transmission occurs when light passes through a subject, like I said, clean, clear air, and is not refracted, or it does not have the light ray course altered at all. It also can occur if we've got a really clean, clear piece of glass and the light rays happen to hit it perfectly perpendicular to the surface. Perpendicular means the light rays are 90 degrees from the surface. They come down, they hit it, they will pass through. So usually if you go outside, the sun directly overhead, you'll just get light passing straight through as long as your glass is fairly clear and clean. Now, as soon as those light rays alter even a little bit from that perpendicular or perfectly 90-degree angle, then all of a sudden they will start to refract and bend as they pass through that surface. So all glass has some kind of thickness to it, and the light rays will bend as they pass through that thickness. So that's called the incident angle, just like it was when we were measuring reflection. So light ray hits the surface at an angle other than perfectly perpendicular or 90 degrees, bends slightly, exits out, continues on its path till it hits something else. Now for us, that's going to make a difference because we need to calculate how many surfaces our rays have to go through. They could be camera rays, they could be light rays, they could be particle rays, whatever you happen to be keeping track of. So you guys have all modeled a glass very similar to this up here, that wine glass, or even just a regular drinking glass. Okay, we have you guys build it just like it is in the real world. It's got an outer surface, it's got an inner surface, and that area in between the outer and the inner surface, that wall, that is defined by the material. That is your AI standard material going, hey, I am opaque. You have to bounce off me. Or in the case of today, hey, I'm transparent, you pass through me, but you need to bend according to my index of refraction. Then once it's passed through, what does it hit inside the glass here? What's inside? What would be in real life? No, empty. Yeah, air. Yeah, air would be in there unless there's liquid. So in this example, it's empty. We have no liquid. So the light rays, once they pass through the AI surface, will continue on their way and obstruct it because there's nothing to get in their way. Hit the inner wall. It'll query the material. What are you made of? Oh, you're glass. Okay, you got to bend according to my index of refraction. And then exit out the other side, continuing on its way until it hits another surface, another piece of glass, or goes out of frame. So in a normal surface like this, an empty glass surface, right? We got light rays coming in. They'll hit the surface. They will bend according to the index of refraction. They will exit, continue on their way, hit the inner wall, have to bend again, and then exit out and continue wherever it's going. So in reality, we've got 1, 2, 3, 4. We basically have 4 surfaces for our ray to go through. It's got the outer wall, it exits the inner wall, whatever is inside, hits the inner wall again, it's got to go through the material, exits the material, goes to another material or air or whatever happens to be out there. So that doesn't sound like a big deal, and it's really not, because when we go to render, generally by default, the render settings will account for at least a glass for light rays to go through. But once you start piling a glass in front of another glass, Then you need to start calculating how many surfaces that has to go through, and you probably need to change your render settings. And remember, the render settings that we change are going to be global. They affect the entire scene. But fortunately, Arnold is fairly efficient, meaning that it's not going to use all those rays on surfaces it doesn't need. Just bouncing off a surface, it doesn't need to calculate transparency or transmission. All right, does that make sense so far? Questions? All right, so here, another thought. What happens if we have another glass behind our original glass? So we've got 4 surfaces for the original right here. We've got 4 surfaces. Come on, really? We've got 4 surfaces here. All right, but the areas where they overlap, what do we have going on there? 8. Yep. It's going to be the sum total of those 2 surfaces, those 2 pieces of geometry. All right, good. So now, what happens if we have liquid inside the glass? So we still have our light ray coming in. It's going to bend according to the index of refraction of the glass. Now it's going to hit immediately another surface. This surface is going to be treated like a solid, right? Think of water. Put a glass of water in the freezer. If you can extract that frozen piece of water out, it will maintain the shape of the glass and be a solid surface. That's how it's treated in CG. It's treated as a solid. Just because it has a name liquid doesn't mean anything. It's still got an entry point. Right here, it's a solid, so that means it's going to bend as it passes through and then exit, immediately hit the next surface, continue on its way. So now, instead of having just 4 surfaces, we've got 1, we've got an exit there, we've got another point here, got the exit point, immediately goes into the glass and comes out. So a glass with liquid in it is going to have how many surfaces for that ray to go through? 6. Yep. 6 surfaces. So now that's what this would have. 6. If you have a glass with liquid in front of another glass with liquid, what are you going to have? 12. Yeah. Now, here's the deal about figuring this stuff out. This is important to the camera. Your camera is really what needs to see through the glass. If you have 2 glasses side by side, they do not overlap to the camera, you do not need to calculate 12. Does that make sense? Remember, it's only to the camera. So if you rotate that camera around, then all of a sudden those glasses start to overlap, then you've got 12 surfaces for that camera to look through. But if you come back around and look at those glasses side by side again, you only have to worry about 6. Not a big deal for a stationary single shot. With an animation, you need to kind of go through your scene and figure out, okay, where is the camera overlap any surfaces where there's glass in front of glass that needs to be seen through. Question? Anything not clear? Be happy to run through it again. Questions in Zoom, anybody?
No, sir.
Okay. Gaetano, questions? All right. So let's take a little look at our scene. So this is the close-up of the Zen garden. So let's do a little quick calculation here. So this bottle is empty. So how many surfaces does our ray have to go through? 4. All right, good. Here's our wine glass. And notice that I've got it above where the wine is. So if we have a glass that's empty, it's going to have what? 4. Now we've got wine inside the glass. By itself, if that were sitting there floating as a solid, how many surfaces would our ray have to go through? Well, no, by itself, the liquid. 2, yes. Now, the reason I'm making that point of breaking them down separately is because that's kind of how you have to think when you've got overlap. And our overlap is right here where the wine glass, the wine is in front of the bottle. So this area, how many surfaces do we have to see through to get completely to the other side? To see that sofa back there. Well, we got 4, we got 4, and then we got 2. So it's going to be 10, yep. The wine bottle is empty, yes. The wine bottle will be empty. The glass is the only thing that's got liquid in it. You drank it all because you were thirsty. Didn't eat any bread or cheese, but you drank the wine. Not judging, just saying. All right, so 10 surfaces. If the camera were to move and it were to swing around where the glass and the bottle were side by side, you wouldn't have to have 10. You would probably only need to have 6 because that is the wine glass with the wine in it. Always look for, I hate to use this phrase, but the worst case scenario. That's going to be the maximum amount of rays that you need in order for the camera to see through everything. We call them rays, but we kind of think of them as surfaces. Because if we tell it to stop after one ray, it'll hit that surface and then stop and not continue on, and we'll get a blank black wall on the other side. All right, so far, pretty simple. So now, when we start adding in refraction, we are going to basically steal all the energy from the diffuse. That's going to be shut down completely. This transmission is going to have the bulk of the energy Remember, we're using conservation of energy. You can only have 100% at any time. So, and up here, we will have some energy. Depends on your index of refraction and what you have set up. But remember, glass is always more transparent than it is reflective. But in the end, we can only have 100% at any one time in the scene. All right, so specular section of the material and the transmission section work together. They are meant to. The nice thing is the specular weight and color stay the same. The default that you get with the AI standard material, the weight's at 1, the specular color's white, that works for glass. However, the thing that we need to alter possibly is going to be the index of refraction. Right? So here is the index of refraction. By default, you get 1.5. Just to give you kind of a reference, the index of refraction, I'm going to call it IOR, for air is 1.0. For water, it's roughly 1.3, 1.32, 1.33, somewhere in that area. Glass is somewhere around 1.5. Some software packages use 1.52, 1.53. Arnold just puts it at 1.5. It's basically average ordinary production, what they call crown glass. The stuff you go to IKEA, you see it all over, that's pretty much what that is. Or you go to Walmart, it's just ordinary average glass. All right, now, when you create glass, like I said, we are stealing all the energy from the base part of the component, the diffuse, but can't always guarantee that just because we have turned up transmission and we've, got specular cranked up, unfortunately, the base does not shut down automatically. We need to shut it down manually. So the base weight goes to 0. So when you make glass base weight at 0, specular weight at 1, specular color at white, index of refraction 1.5, then you jump down to transmission weight all the way up, you got glass. You got clear glass by default. Really easy, except if you want shadows. That costs extra. That costs a couple of brain cells. All right. So specular weight controls the amount of reflectivity, roughness, and index of refraction. Keep it at 1. By controlling all that stuff, it means it controls basically the overall contribution of it. Specular color, keep it white. Roughness, we're going to adjust this now. Specular roughness is only one part of glass roughness. And for roughness in glass, think of a frosted glass. Put a glass in a refrigerator, pull it out. The air temperature is usually warmer than it was in the refrigerator or the freezer, and the glass clouds up because all the moisture in the atmosphere kind of clings to the glass, making it look frosted. In order to get that accurate, we use specular roughness, and there is also a transmission roughness. So whatever you do to one, you want to do to the other if you want to get that true frosted glass look. All right, questions so far? Make sense? All right, transmission section, transmission weight. Like I said, you turn it up to 1, you've got clear glass. Transmission color. This is where color comes from for glass. By default, it's white. White will give you clear glass. If you want color, you add color into the transmission color. Just like light, glass saturates very easily. So you want to keep your saturation level usually under 0.5. Now, when we get into making shadows, this is where we're going to use a couple of nodes. One is called the gamma correct, and the other is called the sampler info node. So we'll get into that in a second. So here is the extra roughness control you need to use under transmission. It is called extra roughness. So here's an example of specular roughness only. Here's an example of extra roughness only. And here's an example of both of them together. So you go to Arnold's website and you go to their material, the AI standard material, and you go under glass. They say if you want to have accurate results for frosted glass, you need to use the specular roughness, the transmission extra roughness to give you true frosted glass. Now, to add a little bit of extra sparkle to the glass, there's a couple of other things we're going to do. And two of them are under the advanced section of the material. So there's a little switch to turn caustics on, which will give you a little extra sparkle in the glass. Unfortunately, we don't get the same degree of sparkle that we get in the real world with that picture that I had with the sun hitting that glass, but it does add a little bit. And the other is we turn up what is called the indirect specular, which will boost and kind of push the reflectivity a little bit so that we get accurate reflections bouncing around inside the glass. Without that, the glass tends to look a little dark. If we are using the glass for a window, then we turn on what is called thin-walled, and that's under the geometry section of the material. Now, thin-walled will basically allow you to take a solid object, like a sphere, and when you render it, it will not treat the sphere as a solid, it'll treat it as a hollow, thin-walled ornament. Now, the reason we use that is because for window panes, we are not actually going to model the thickness and depth of glass, right? Usually for windows, you throw a plane on them. What we want from the glass is for it to be transparent, for it to be a little reflective, and we don't care about refraction and we don't care about shadows. We only use thin-walled for window glass. Or if you're doing like a special kind of thin-walled ornament. Does that make sense? Like I said, we'll try and demo this as much as we can before we actually start working on one of the objects in there, or a couple of the objects. All right, so a couple of quick renders here, what the index of refraction looks like on a sphere. It's just got a shadow catcher under it. It's got a dome light in it. That's pretty much it. Oh yeah, and a directional light shining in through the window. So here, index of refraction 1.0, you can't really see any reflections. You can't see anything. In fact, if I didn't have a sphere there, or I didn't have a shadow catcher under the sphere, you wouldn't believe I actually had an object there. So that shadow is only there to show you, hey, you know, air is the most neutral material that we have. So increase, same sphere, same material, increase the index of refraction to 1.33, which is water. We have reflectivity, we have transparency, we also have refraction. Light bends as it passes through. 1.52, denser, reflects more, refracts more. Get into a diamond, which is a really solid, dense material, 2.42 or thereabouts. And you can see we have a lot of reflection, a lot more reflection, and a lot more refraction. Light bends a whole lot as it passes through. So changing the number, usually the higher the number, the more the rays will bend. Now, for our render settings, everything usually works along pretty good. Usually set your, camera AA, your diffuse. Last time we talked about increasing the specular a little bit. Now with glass, you may notice that your specular may look good, your indirect light may look good, but all of a sudden, all those glass objects have a little bit of noise in. This is where you will probably need to increase the transmission as well. So just like all the other settings like diffuse, specular, transmission, even subsurface scattering, preview quality is going to be 2 or 3, medium is going to be around 4. Medium, high is going to be 6. High quality is going to be 8. Just remember, as you start increasing this, it will increase your render time. So be prepared for your renders when you start doing them to take longer than they did in Project 1. Because in Project 1, they were big environments, but the material was simple. Straightforward AI standard surface, all diffuse, nothing special. Here, you've got reflectivity, you've got transparency, you've got a lot of stuff bouncing around all over the place. You've got reflections, you've got refractions. That all starts to take its toll in your render time. So prepare for an extra 15, 20 minutes, maybe even a half an hour at the worst. So it's one of those things you want to be absolutely sure before you kick off a final render. Do small crops. Go in different areas of your scene before you commit to a full render. And when you do, let it run, walk away, go to sleep, whatever. All right, now, a couple other things to worry about is the ray depth. So how far do the rays go? All right, so we got a couple things here. We got a total, which by default is 10. Okay, you can see we've got 1 ray for diffuse, which usually works out pretty good. 1 for specular, that works out okay. Sometimes you want to bump that up to 2 to get a little more reflection. Transmission by default is set at 8. So it's 8 plus specular, which is 1, plus diffuse, and the total is 10. So 8 works pretty good for glass in front of glass, or even glass with liquid in it. But when you need to add in another piece of glass, like in our Zen garden close-up, you've got to account for the extra surface. So we talked about the Zen garden. It actually had 10 surfaces for the ray to go through. So here you would have to crank up the transmission to 10. Probably put that at 2, probably keep that at 1. So all these together would mean our total is what? What is it? Yeah, 13. We got 10 for transmission. I cranked up the specular to 2. And then the diffuse is at 1. So 13. Now, transparency depth down here, you generally want to change that to be whatever your total is also. Because you want to be able to see objects on the other side of your glass. You want to be able to see diffuse objects. You want to be able to see reflective objects. You just don't want it to stop. So that whole transparency depth, keep it the same as your total. Like I said, diffuse, we normally keep that at 1 because we got a lot of indirect light bouncing around anyway. All right, questions about that part? Does that make sense? Questions in Zoom?
No.
Okay. All right, so as I mentioned, camera angle makes all the difference in the world. So this is with an older version of Arnold before they had the denoiser put in there. And the render up top, I had very little glass overlap. And the glass objects were roughly 6 to 8 feet away from the camera. Took an hour and 6 minutes to render. All the settings were the same. All I did was move the camera in for a close-up on the table with some glass overlapping. And it basically doubled my render time. So be prepared for an extra render time if you've got a lot of overlap. Now, the reason I mention this is because in the long shot, you may not have as much overlap as you do in the close-up, depending on what your objects are made of. So not a guarantee that it'll happen to you, but it's always good to be able to plan for it if you happen to see, oh yeah, I got glass in front of glass. All right. Let's make a little glass in the exterior scene. So first thing I'm going to work with is going to be the wine glass. It's clear, fairly simple to make, and we'll kind of go through the troubleshooting process, the process of actually making glass, and solving the transparency, not transparency, but the shadow issue in Arnold. All right, now, first thing you want to do whenever you're making anything, find reference. Let's go images. Let's go large. All right, so what makes good reference? Well, like I said, for our purposes, you do not want to have solid looking liquid. We need to be able to see through it a little. All these wines are way too dark. So that's kind of a Zinfandel, a blush, a rosé, whatever you want to call it. That would be fine. That one would be fine. White wine's generally not a problem because it is a lot clearer than the reds. So let's just say wine glass outside. See if we get any different results. All right, size, large, there we go. All right, so something like this would work for either the white wine or the red wine. So it's red, but we can still see through it. Something like this, you can kind of see through it. The thing is, you got to watch out. That looks like CG because it looks like that glass is floating on top of that wood. So don't use that. So here we've got kind of a Zinfandel blush rosé kind of wine. Too dark, can't see through it. Looks like super dark grape juice. Like I said, for our purposes, we need the red wine to have some transparency in it. That would be acceptable. Really dark wine, but you can still see through it. That one would work. Can see through it a little bit. Not really the best because it's really kind of hard to see the rest of it. So if you know the kind of wine you want, you can specify it. Specify red wine, specify white wine. Specify, well, rosé, muscatel, which I think is red, is kind of pink. Blush, whatever you want to call it. All right, so for our purposes, what kind of wine should we make outside? We got white, you got blush, pink, rosé, whatever you want to call it, and red. Red, okay. How about red wine? And let's just make sure size is set to large. Nothing worse than finding the perfect reference and have it be a thumbnail. Doesn't really work. So this one, that's pretty good. That's actually not bad. Doesn't really have a noticeable shadow in it. Really kind of soft, a lot of indirect light. Let's see. Oh, we got shadows here, but the wine is too dark. Kind of got shadows here. Little faded. That looks like CG. That's no good. Remember, you got to have some kind of background environment for, cut for light and for reflectivity. Which one? Bottom row. This one. Goblet of wine. Yeah, that would probably work. You can see through it a little bit. Actually, that's not bad. You can kind of see through the wine, okay. Here's another one. That's not bad. Kind of dark though, a little too solid. This one, the thing I'm worried about is it looks transparent because we're looking at it really close from the top. I'm not sure that our camera angle is going to work there. Yeah, it might. We can try it. Save image. Let's see. Desktop. All right. So that part's good. Got some reference. Let's open up our scene. Launch Maya. All right, there we go, finally. Pull that up. Set my project. Let's do the Zen garden. I'm going to demo the day because we did the night for the lighting. All right, so don't forget Zen garden, got to be in perspective, render cam, and then under view, you can change your bookmarks. All right. So AI standard surface assigned to everything. Let me just make sure that all the dome light image saved. Okay, it did. Good. All right. So we've got reference. Next thing we want to do, assign a new AI standard surface to the geometry. In this case, it's going to be the wine glass. So Shift T, Arnold, shader, AI standard surface. So by default, we get standard issue, speculars on, base weight, values really high. So for glass, first thing we want to do, turn off the base weight. I'm also going to turn down the roughness for now. So now we've got a fairly dark, fairly reflective surface. So weights, the base weight's at 0. Specular weight stays at 1. Specular color stays white. Roughness I turned off just so we can see. Index of refraction by default 1.5. That is glass, which is good. Next, under transmission, we turn weight all the way up. And now we've got nice sparkly glass. But what happened? Well, we've got a blob of clay sitting in the glass and the shadow from that blob of clay. But notice we have no shadow from the wine glass itself. We had a shadow when it was opaque. And a lot of people say, well, can't you just turn down the transmission weight a little bit? Well, you can, but then you wind up with glass that looks like that. That's not clear glass. So this is the problem with Arnold. Easy to make glass, but you need a shadow for an object like a wine glass. So this is where we use two Maya utilities. Now, utilities sound scary. You don't know where to get them. You call up, utility service. Hey, just like my internet, I need some Arnold utilities. No. Under transmission, in the weight attribute, we click the input button, and that brings up what's called the create render node. In the create render node, there's a lot of things you can plug into that attribute, but we're not interested in plugging textures or outside files in. We want to plug a utility in there, which is basically a Maya little piece of code that helps us make that shadow. So we go under Maya, we go to utilities. All the utilities are alphabetical. The first utility we need is called a gamma correct. So it's going to be under G. G-A-M-M-A. So I go down to the G's, and fortunately, it's the only one there. So I click on it, and that brings up a connection editor, because right now it doesn't know how you want me to connect it. Well, we plugged this into the value of the transmission. So we want to take the gamma correct out value right here. Notice we get three attributes, X, Y, and Z. It's 3D. We only care about value X. So now we want to plug it into the material. So the gamma correct out value X, we want to plug into transmission, which is on the right here. So plug that in, hit close. So now our gamma correct is plugged into the transmission weight of our material. Now, just to kind of visualize this, I'm going to open up the hypershade so we can see exactly what happened when I did that. So here's our AI standard surface 1, AI standard surface 2. Honestly, I'm going to rename that so we get what it is, wine glass. I should have renamed that when I first made it. There we go. So wine glass. What I want to do is graph this. Now, graphing will throw it down here into what's called the node editor. Node editor is basically the hypershade. It allows you to view what a material, what a node looks like. Anybody ever done any work in Unreal? Unreal is built completely on nodes when you go to start assembling materials and textures. So now, easiest way to get this in here and have it all graphed out is to right click on it and go graph network. You got a little contextual menu, graph network, right click. There's my standard surface shading group, which is what the renderer gets all the information from. Here's my Arnold material, and here's my gamma correct. And you can see my out value, X, is plugged into my transmission weight right here. It's just called transmission. So right now, that really isn't doing a whole lot for me. There's a few things we have to change. First is, since we're using the X value of this gamma correct, we want to boost it. So we change it to 4, and we turned, which 4 is an X. We take Y, take it to 0, and Z, take it to 0. All we're doing is setting up a boosted correction for the shadow. Now, in order to get the actual shadow, we need to have the camera be able to figure out what it's looking at. And for that, that's called a sampler info node. And the sampler info node gets plugged into the gamma correct. So here it is here, gamma correct value. Click on the little checker button, brings up the create render node again. We're not interested in any of these textures. We want to go back to utilities. And we want a sampler info node. It's under S for sample, sampler. So sampler info right here. Click on it. Brings up the connection editor again. And basically what we want out of that sampler info is called the facing ratio. That means we want it to sample whatever the camera is looking at. So facing ratio, and then under value, we want to use value X, which is what we just boosted in the gamma correct. So we turn that on, and mysteriously, we have a shadow. All right, let me Z back again. Do that one more time. This time we'll be able to see it in the render while it's going on. So gamma correct, X value is 4, Y and Z are 0. Gamma correct value, click the input button, brings up the create render node. We want to go to utilities. And we want to scroll down to sampler info. Right here, we want the facing ratio, because that's basically telling the sampler info, whatever the camera's looking at, sample that. Facing ratio, we want it to go to the X value of our gamma correct right there. And now we have a transparent shadow. All right, so this is what our new network looks like now. We've got our sampler info. It's connected into the gamma correct. The gamma correct is driving the transmission. And now that object has glass and will have a shadow however the camera looks at it. Just like it would in the real world. If you were to walk around the glass sitting on the ground, you'd be able to see the shadow from all different angles. Does that make sense so far? Now, the good news is that I actually have a checklist for you similar to the metal making metal. It's making glass, and it's got all the steps in it. Now, once we're done that, there's one other thing or a couple other things we need to do. So I'm going to select my material in the outliner. And I want to scroll down in my material attributes to advanced. Let's take a snapshot of that. Under advanced, I want to turn on caustics, which will give it just a little bit more sparkle. A little bit of sparkle here. Really makes it come alive. The glass is still looking a little dark here, so we're going to boost the indirect specular to 1.1. All right, let me go back to 1. Wait for this to finish rendering. Good enough. Let's stop that. Oh yeah, there's my problem. Get rid of that denoiser. I really don't need it denoising on me all the time. I forgot that was on there. Let me check my render settings too. Okay, that's good. Default. All right. Let's go back to the material. Let's kick that off. And now let's take our indirect specular, boost it up to 1.1, makes the glass a little clearer looking at it directly. That's what it looks like with the default indirect specular at 1, and this is 1.1. All right. So this is just getting the shadow. We've added in this render, this is caustics. You can see it's a little bit more sparkly. Caustics, and now this is caustics and indirect specular boosted. Don't worry, Gaetano, we're going to do it again for all the other objects. And I'm also going to give you the checklist for making these objects. And also, you have the advantage, you can go back and watch the lecture again if you need to. All right, so like I said, I know it seems like a lot. It seems like way too much. But when we go to do the liquid and we go to do the wine bottle, it's going to be the same process. So after a couple times, you get pretty good at it. So let's review the process that I did so far. So first, find reference. Assign your new AI standard to the geometry. You turn the base weight off, specular weight to 1, which is default. Specular color, default, stays at white. Adjust the specular roughness and transmission roughness. I like to do that after I'm done because glass usually has very, very low levels of roughness. I mean, most of the time we want glass so we can see through it and see what's inside of it. That's part of the aesthetic appeal of, a drinking glass like that. Ooh, look, iced tea. Ooh, soda. Ooh, juice of some kind. All right. Just the index of refraction. Like I said, the default is glass, which is 1.5. Transmission weight, turn it up, you got glass, but no shadow. To make a shadow in the connection editor, well, to make a shadow, the transmission weight, we plug a Maya gamma correct utility into. In the connection editor, when you plug it in, under outputs, we select out value X, and we plug it into transmission. Screenshot right there. We close it. Then inside the gamma correct, we change the gamma X value to 4. Y and Z go to 0. In the area right above, in fact, let me bring this area back here. There it is. So gamma 4 in X, 0 in Y and Z. In the value section up top, this is where we plug our sampler info node into. All right, so sampler info node, we select facing ratio in the connection editor, and it gets plugged into value X. We close it, should have a nice shadow. Now, transmission color, based on your reference, if it's clear glass, it stays white. We'll get into making the liquid inside the glass a different color. So you always want to go and turn on caustics and increase the indirect specular to 1.1 in the render settings, Arnold renderer. Under sampling, ray depth, increase the specular transmission. as needed. You're also going to increase the specular and transmission samples in the top part of the renderer. And then when we get into making window glass, we're going to turn on thin walled. We're not going to do that yet because that requires a different scene. There is no window glass in the Zen garden. Right, so let's do the geometry inside the glass. All right, so there's the wine geometry. We go into wireframe. There we go. Now, don't expect to see this glass transparent in the viewport. Viewport cannot show ray tracing materials accurately. So there is our wine geometry. All right, so we're going to use this. We've already got reference, which is this. Assign a new AI standard surface. All right, so select it, Shift T, Arnold AI standard surface. Call that red wine, so I know exactly what it is. Okay. Next, let's turn off the base weight. So if I hit render, we get that. Let's turn off base weight. Now it's really dark, like tar, prune juice. We're going to keep the specular weight at 1. Specular color. I'm going to turn the roughness down. Why? Well, take a look at the wine glass with the wine in it. Those reflections are pretty hard and clear. There's not much in the way of roughness in it. Yes, Kayvon. Did you assign a brand new AI standard surface to the new geometry? It sounds like you accidentally selected all the initial AI standard surface you had in there. So what I would suggest is select your geometry, double click, see what it's set to. If it says AI standard surface 1, that's your initial geometry that you assign, or your initial material. Assign a new material to it. All right, so low roughness, going to turn that down. Pretty hard reflection, which is fine. All right, index of refraction. So now we need to figure out what is the index of refraction for red wine. Easiest way to find that is look on the internet. It's where you look for everything else. Index of refraction or refractive index, that works also. Nope. Let's try this one. View full PDF. No, $10. No, thanks. All right. How about this? All right, this will work. So 12 red wines. We've got a choice of, it looks like index of refraction is going to be 1.34. So the last digit, there's going to be 3 digits after the decimal. So that looks like that's going to be the key, 1.34. 1.343, 345, 344, 343, 346. So probably 1.344 somewhere right in the middle. That's going to be our refractive index. So let's go back to Maya. Down here, 1.344. Again, based on what we found on the internet for the refractive index of red wine. Now, next, we found the refractive index. If we turn up the base or the transmission weight all the way up, well, we've sort of got water, clear water. But this is where we want to have a shadow to go with it, because we don't have much of a shadow inside that glass. So let's do our steps. So the first thing, we're going to plug a gamma correct into the transmission weight. So transmission weight, checker button, create render node. We don't want any of these textures. We want utilities. We want a gamma correct. It's alphabetical. We go under G, which is right here. In the connection editor, we want the out value of our gamma correct, out value X. We want to plug it into the transmission, which would be the transmission weight. We click close. Under gamma correction attributes, X is going to be 4, Y and Z are going to be 0. So 4 for X, 0 for Y, and 0 for Z. Next, this is where the transparency part comes back. Under the value in the gamma correct, we click that little input button, create render node again. We go under utilities. This time we want a sampler info. So that's S. Sampler info. For the sampler info, facing ratio on the left, that's whatever the camera's looking at. On the right, we want the value. The value's grayed out, but you got to click the little plus button, value X. Now we've got a shadow inside our water. So that takes care of that. The last thing is transmission color. Now for that, we need to go back to the material. So I'm selecting the object, red wine, AI standard, transmission color. Easiest way, use the color picker. Remember what we did last time in lecture for metal. So I'm going to double click in the transmission color. That's going to bring up my advanced color picker under color wheel, image, going to hit load. My image is on the desktop. There's my wine. And I want to sample a nice area that's going to be kind of light, but not too dark. So I'm going to click close. All right, so that wasn't too bad. Now, if you pick too dark of an area, remember, if it's really dark and it's got a lot of value in it, that's going to act like cutting down your transparency. It's going to be harder to see through a really dark color. All right, now I can go back and I can add a little roughness to maybe the glass. But the glass, I mean, you know, wine glass is usually going to be fairly clear, but for a little realism, maybe 0.01. And I would do the same thing in the transmission. So I put 0.01 for the glass in the specular roughness, and then under transmission, extra roughness, 0.01, just to give it a little imperfection. And I could do the same thing with the wine inside. That wine looks fairly clear. Most wine companies will filter their wine. It's not like it's going to be full of particles floating in it, unless, of course, it's really nasty, which in that case, don't drink. All right, so that is kind of the overview for doing that. Let me take a screenshot of this and upload it for you guys in Zoom so you can download it. Say again. I can, however, if I upload it to Discord, everybody gets it, and you guys, since you're campus, get it first. So the online people, unfortunately, it sounds like I'm being a jerk, but the whole idea with campus is you guys get more contact time. You guys get the perks of being here on campus. Online, they basically have to stop this and take a screenshot. So, you know, it's kind of nitpicky. I probably will put it up there on Discord tomorrow, but not today. All right, so let's see, making glass. (2021-09). Let's drop it in. There we go. And actually, what I can do, let me go to FSO. Let's see. Let's go back here. And let's message class. All right, so everybody should have a shot at getting that now. All right, so hopefully that helps, kind of makes sense. It's a good time to take a little break. What we'll do is we'll take a break. That'll give me a chance to upload this part of the lecture. We come back, we'll do the wine bottle. We'll go into the interior, do a couple of objects in there, and I'm going to show you how to do the glass in the windows, because it's just a little bit different. Okay, makes sense? Questions before we go on break?
No, sir.
Okay. Gaetano, questions before we go on break? Yep, review the steps. We're going to go over them quite a few more times when we come back. So like I said, don't worry about it if you don't get it initially. It's just like practicing scales. So the more you practice, the better you get on your instrument. Your instrument happens to be the AI standard material. All right, so we'll take a short 20-minute break. Let's see, let's come back at, where are we? Let's come back at 2:53. I'll see you guys in about 20 minutes.